should start in here. Okay, so today's week 4, Thursday. Well, almost done with the summer session 1. So time really fly by quick. So PA4 is still this coming, not just this Sunday in a few days, right? So the 30th, so that's when PA4 is due. The last assignment is PA5. The last assignment is about steganography. Okay. So next week, around before next week, tomorrow we have a quiz, right? And that is the last quiz. We don't have a quiz in week 5. Week 5 on Saturday we have a final, and that's it. So this week we have the lab, and next week we have a lab, and then the final and the PA. So that is the plan. Don't forget the quiz tomorrow. Okay. Are there any questions before we start? The goal is we'll finish steganography, and then we'll get started with dictionaries. Next week, on Tuesday, we'll kind of finish dictionary, CSE file processing, and then on Thursday, depending on where we are on the content, I may just open up it for Q&A, or we can look at the past final. I think I've posted a final. And let me see. So for 8A, I think I may have posted a final exam in here from 2021. So you can use this as a reference to say how I should prepare for the final. Although this final is closed book, closed notes in a classroom. So our final will be on Gradescope. It's all multiple choice. So it's going to be different from here, right? But are there anything folks have questions with before we start? Is it similar to the midterm? Yeah, it will cover everything from day 1 until the last day of class, like this coming Tuesday or even Thursday. But it will be similar. You can expect more questions though, in the final. Yeah. And it's open book, open notes, open Python coding environment. Any other questions? All right. So let's get started in here. Last time we talked about steganography, right? And today we're going to look at some of the bitwise operations that would allow us to achieve the effect of steganography. And then I will talk about the general idea of how to do steganography. That's what you need to do for PA5. And then we'll move on to dictionaries. So first, what is the idea of steganography? So basically you have the image that you want to hide. We call this the secret image. And then you have this context image. The context image is like the image that you will send around without people knowing that something is hiding in there. In general, the size of the context should be bigger than or equal to the secret message, secret picture. In general, that's the case. Okay. And what we have is you have this secret message and you want to hide it in there. How do we do it? You look at each of the pixels from the secret message. For example, if this is a picture in here, so you take a pixel in here and you find the corresponding pixel in the same spot in the context image. Supposedly, if this is the pixel in the context image, this is the pixel in the secret image, they have the same XY location or ijth location, same row, same column. And what we do is we know that the secret image is RGB, the first few bits, for example, the first 2 bits, they really play an important role on the color of the secret image, right? So they dictate what's the color. And what we will be doing is we will be copying them into the last 2 bits of the context image. That's it. So in other words, for each of the context image, the color changed a little bit because we are changing the last few bits. They do not cause a big impact on the color of the pixel. So the context image will look slightly different from, I mean, if human eyes most likely won't be able to even see it. But there is a small difference, okay? Without human realizing it, you send this picture around, and once it reaches the receiver, what you do is you basically have the so from the receiver point of view, we'll come back to this again today. So from the receiver, you have 0, 0, 1, 0, 0, 1, and 0, 1, like this RGB in here. Right, this is red. And the last 2 bits is what we really cared about. And you have 0, 0, 1, 1, 1, 0, 0, 0, the last 2 bits. Oh, sorry, the last 2 bits is not 0, 0 anymore, it's 1, 1. And then you have 0, 1, 1, 0, 0, 1, 0, 0. What we'll be doing is the receiver would grab this pixel, RGB value, and then put it like this. This is to reconstruct, recovered. And you move this one over here. To charge my status. So this one would move here. You see 1, 1. Something is not right in here. So fill in the 6 zeros, and in here is the same thing. 0, 0. Okay. So these last 2 bits before will be moved to the left side, and then you'll mark them as the leading 2 bits, and you fill in these zeros. In other words, if you look at the secret message pixel compared with the recovered pixel, you lose some details from before, but you will still be able to identify it's a secret message. It's a secret message. Okay. Any questions about the idea? We'll come back to the idea again, but as of now, is it clear about what we will do when we do steganography? All right. So we'll look at bitwise operations because you need these tools in order for you to do these things, like move things around, put things in different spots. So we'll look at bitwise operations, okay? And this is the major learning goal for today. Okay. How do I do bitwise operations? For bitwise operations, what we need to look at is the following. The first thing is bit shifting. You can move things around. You can shift things to the left. You can shift things to the right. In this class, we use right shift a little bit more often. Okay. So what do you mean bit shifting? If you view a number in binary, for example, 0b, right? This is a binary number. You say this number right shift 2 positions. It means get rid of the last 2 bits, append 2 zeros in the front. That's what it does. If you say left shift 2 positions, you used to have this thing. You're gonna append 2 zeros in the front, at the very end. That's what you do. So you're just moving these bit patterns either to the right. If you move to the right, the trailing positions they'll be wiped. They'll be thrown away. If you shift to the left, you are basically appending zeros at the end. Um, any questions about this? Let's do a quick vote in here. If I have 6, left shift 2, 6 in binary is 110. Okay. If I left shift 2 positions, what would I expect to see here? You can vote in whenever you're ready. Okay. Right. So we'll stop the vote here. We disagree with each other quite a bit. So a lot of us said 24 or none of the above. So if you think about 6 left shift 2 positions, you have 110, left shift 2, you append 2 zeros. So what is this value? You can convert it into decimal. I can tell you it's 24. Okay. How come? The idea is, in fact, if you say 6 left shift 1 position, whenever you left shift 1 position, you are multiplying by 2, roughly speaking. So if 6 left shift 1 position, you get 12. And then you left shift 1 position again, you get 24. That's what you do. When you right shift, you are basically divide by 2. So right shift is divide by 2. And this is integer division. Just be careful. Okay. So do I have to convert things into binary? It's better you view it as a binary number, but technically you can just provide the decimal equivalency of the number, and then it's gonna do the operations on binary, then convert it back into decimal for you. Because machines only deal with binaries. You're just kind of playing with decimals for humans. You know. Any questions about this? All right. How about this one? 20 right shift 1. 20 right shift 1. What do I end up with? Okay. So we'll stop the vote. 20 right shift 1 position means 20 divided by 2. So you get the 10. C is the right answer. Okay. It's not 2. You are always dividing by 2. Dividing by 2. So 20 divided by 2, you get the 10. If you right shift. If 20 left shift 1, you are looking at multiply by 2. That will give you 40. Okay. How about 10 right shift 2? What does that give me? 10 right shift 2 positions. Right shift 1 position means divided by 2. How about the right shift 2 positions? All right. So I don't think we're getting this one yet. Well, at least I think people are voting for B or C, right? So the answer is if 10 right shift 1 position, you get 5. Now 5 right shift one more position, in fact, you get 2. This is integer division. it's never about like a whole number division, like a floating point division. So 5 divided by 2, you get a 2. Okay, you don't get 2.5. Um, any questions? Just be careful in here. Now, how about 10 left shift 10 positions? What would you say the answer is for this one? All right. We'll stop the vote in here. A lot of us said B, right? That's correct. If you think about left shift 10 positions, basically you are multiplying this number by 2, 10 times. That's 1024. So 10 times 1024 is 10,240. That's what it is. Okay. So you can keep shifting to the left, shifting to the right. You may say, why do I need something like this, right? What's the point? It goes like this. For example, you have a RGB, right? This is the secret message. So I really need to get the first 2 bits of R. For example, this R would have 8 bits, R1, R2, R3, R4, R5, R6, R7, R8. And I really need to get these 2 bits. What should I do? If you say I need to get the first 2 bits, the most important bits of R, this would give you basically a value of 0, 0, 0, 0, 0, 0, R1, R2. This would give you the first 2 bits of R, and you have moved them to the end. That's what we have. Any questions? So using shifting, you can move things around. Is okay, I already have this thing. How can I move them to the left side? And then you this thing left shift to 6 positions. You got R1, R2 with a bunch of zeros. So that's what we're looking for. You can kind of extract the patterns, okay, by moving things around. Especially when you shift to the right, you're erasing a lot of information. When you shift to the left side, you are not shifting things out. In other words, if you say at this number, you left shift a few positions, you are not going to wipe clean the left side. Python doesn't do that. So you're just appending zeros at the end. So this would allow you to grab the first 2 bits or like move them around, move them around. Any questions about shifting in here? Left shift, right shift. Um, next thing. How about this one? As x equals 25, x right shift 2 positions, then print out x. What would I expect to see be printed out in here? All right. So let's see. A lot of us said A6. In fact, unfortunately, the answer is still 25. Right. So why is this the case? Let's come here. Okay. Let me do a quick demo. This PAs. This is lecture today. So let me do a demo in here. Okay. So we say Python. And if I say x equals 25, and I say x left shift, is it left shift or right shift? Doesn't really matter. Right shift. Okay. X right shift 2. And then I print x. X, in fact, is still 25. So when you right shift this x, indeed I get 6, right? 25 divided by 2, and then divide by 2 again. So I do get 6. But this statement would not change x. If you really want to say, I want to change x, you have to say x equals to x right shift 2. This now would change x. X is now 6. Just be careful. When you want to change a variable using shifting, you have to do the shift and then assign the result back into that variable. Otherwise, that shifting would create an intermediate result and it got thrown away. The original variable was not updated. Any questions about this? So be very careful. Okay. Um, Now, so we know shifting, left shift, right shift. Another two operations you can do is called AND and OR. This is called bitwise AND, which is this symbol here. So it means you have two numbers, they're going to be ANDed together bit by bit. This is the first bit, this is the second bit, and this is the result. So if you look at it, for the first row, second row, third row, only when both bits are 1, the output is 1, the result is 1. If any of the two bits are zeros, then the result will be 0. That's AND. You can think 1 is true, 0 is false, so only when both of them are true, the result is true for AND. Similarly for OR is this bar, a single bar. So when you look at OR, when both inputs are zeros, the output is 0. If any of the input is 1, the output is 1. So it's 0 or 1 equals 1, 1 or 0 equals 1, 1 or 1 equals 1. That's how you do the operations. So why do I need them? Because if you look at bitwise AND, anything AND with 0 equals to 0. So for example, if I say I have this number, I say, can you please wipe clean this bit and this bit? Whatever they are, make sure they are zeros. After I do the operation, you can try to end it with this number. So I want to leave everything else unchanged. I only make those two positions 0. And if I do the AND, this is 1, this is 0, 1, 1, 0, 0, 0, 1. So what does it mean? Only these two bit positions are changed compared with the original number. Excuse me. Only these two positions are changed compared with the original number. Everything else stays put. So anything end with 0 equals to 0. You can use zeros to wipe clean certain positions. Anything end with 1 equals to itself. It means unchanged. So what AND will allow you to do is to clear certain bits. You can create this thing. This thing is called a mask. Oh, to be more precise, a bit mask. So you can use it to, you can design a pattern in the bit mask to achieve your goal. Now, how about OR? OR is used to set certain bits. For example, you say, I have this number, I said, can you make sure that these positions they will be ones, no matter what they used to be before. And I say these two positions, they must be ones. All I need to do is I design mask, I do the OR operation. Everything else is zero, but I make sure that these positions are ones. If I do the OR operation, you'll see this is 1, 1, 0, 0, 1, 1, 0, 1. So in this result, this position and this position, they're guaranteed to be 1. Nothing else will be changed compared with the original number above in there. So that's what OR does. You can make certain positions once. In this class, at least with steganography, we use bitwise AND more often. Like for example, when do I use bitwise OR? If you are controlling a robot using a small device, a lot of times you have to set the voltage of a certain pin to be 1 if you want to turn on the motor, 0 when you want to turn off the motor. So, and usually those pin numbers are stored in a binary sequence. You can use the bit pattern to set something to 0, to set something to 1, and that would allow you to control the robot, for example. Okay. So the bitwise operations we learned so far today is shifting, and then AND, and then OR. Okay. Any questions about them? Let's vote in on this one. Of this number, binary number, and with another binary number, what is the result? All right. So I think a majority of us voted for D. Let's check. Right. Um, so you got to align the bits together, and then 1, 1, 1, 1, 0, 0, 0, 0. You AND. Remember, anything ended with 0 will be 0. So if whenever you see a 0 in that column, the result will be 0. Only the first two bits are 1. So D is the right answer. D is the right answer. Okay. For AND, whenever you see a 0, you get a 0. How about OR? The same numbers, I believe, they are ORed together. What would you say the answer is for this one? All right. I think a majority of us voted for B. In fact, 100% of us voted for B. Let's see if we're all right or all wrong. 11001100, and then you OR with the other number. This is the OR operation. So whenever you see a 1 in that column, you end up with a 1. So in fact, all of us are right. Right? So the answer is B. The answer is B. Any questions? So these bitwise operations, left shift, right shift, and or would help us to obtain what we want to do. Let's look at these two exercises in here. And the first one is get the last two bits from the red and return it. This one is you are given two integers, and your job is to put the first two bits of this one into the last two bits of the other one. Kind of similar like what we are supposed to do in steganography. The challenge is here. Okay. So can you all finish this? Try to work on this challenge in the Zoom chat, and then give me a vote once you are done. Okay. Then we'll work on them together. To change these two methods. Try to work on these two codes, and I'll give you another 2 minutes. Okay. And you got to think about how to test your program, right? No one is done yet. Interesting. This one is looks like it's gonna be a little bit tricky, huh? All right. Um, maybe we should just work on it together. I'll give you 1 more minute. I mean, work on one of them. The second one probably will be similar as the first one. You got to think about the number like red, think about it as a binary sequence, and that would tell you how to solve it. Feels like my computer is slowing down because it's processing the video from my previous class. Um, all right, let's just work on this together. It looks like none of us are able to finish this one. Um, so how do I do this? First thing, get red. This one would get the last two bits of red and return it. The way you would think about it, okay, what's red? Red, you can think it's a number, right? In general, we think if we are looking at RGB, it's 8-bit long. And then so I need to get the last two bits. I can't shift because if I shift, I'm just gonna append zeros on the right side, and it's not gonna get rid of this. I need to get rid of them. So I can try to use AND. When I say get rid of them, it means change all of them into zeros. Yeah. So I need to simply do um an AND operation here. So I will simply return red and with this binary sequence 0, 0, 0, 0, 0, 0, 1, 1. That's it. Just by designing this bit pattern, the first 6 bits would be wiped clean for me. The last 2 bits are kept intact. Whatever they are, anything ended with 1 equals to itself. And that's it. That's the first one. Get to the last 2 bits. Is there another way to do it? Yes. Another way to do it is you say I want to get the last 2 bits. I simply return red mod 4. That would also work. Mod 4 will basically say what's the remainder. And if you think about the remainder, it's always going to be the last 2 bits, whatever the last 2 bits is. So either way is fine. If you're looking for the last 3 bits, it's mod 8. Last 4 bits is mod 16. It's always mod 2 to the power of something. Okay. Any questions about this get last 2? All right. So the next one, puts the first 2 bits of red 1 into the last 2 bits of red 2. Let me draw it in here. So red 1, you can think it is like this, right? 8 bits. Red 2 is like this. Yep. So the first 2 in here, put it in there. So the first thing I need to do, I need to extract the first 2 bits. How do I extract the first 2 bits? You can do the AND and then right shift, or you can simply do a right. The process goes like this. First thing, step 1 is, if this is x1, x2, I want to get this thing. Right, so I want to get x1 and x2, and they are at the end in here. And by doing this, I can say red 1, right shift 6. That would do it. And now I need to put it into the last 2 bits. How do I put this thing into the last 2 bits? I can, step 2, that I can do is I can make red 2 this thing. I wipe clean the last 2 bits. By doing this, it's gonna allow me to get ready to merge them together. So this is kind of what we have. Sorry, I think it's a little bit slow for some reason. Something is going on. The computer is doing something. Now, when I try to merge them together, uh, So how do I get this thing? You can say red 2, you um you can say I will be ending with a mask, right? I will just keep everything the same, like in the first 6 positions, and the last 2 will be zeros. If I end them like this, the last 2 bit positions will be wiped clean. The first 6 bits are intact. And then step 3, I can just add them together. Anything added with 0 equals to 0, sorry, equals to itself. And that's what we have. So simply adding these 2 results together, and that's it. So this is the steps. So we can say return. Um, let me delete this thing. I think this thing is slowing down my computer. There's too many things written in there. So what should I return? I should return red 1. I want to right shift 6 positions. Make sure you parenthesize it properly. Okay. Because these bitwise operations, they have pretty low order of precedence. In other words, they're done in the end. So you do not want to cause any confusion. So make sure you parenthesize all the bitwise operations to avoid problems. Plus, red 2 and with that mask 0b 1 1 1 1 1 1 0 0, and that's it. So a single return statement. Let's test it out, right? So I say Python test dot dash I test dot py, and this dash I would say run test dot py and then get into the shell. So I want to do something here. So let's, for example, I say x equals to 0b. I'll try to look at this get last 2. I'll say maybe red equals to 0b 1 1 0 0 0 0 1 0. Okay, that's red. And I say get last 2, I pass in red. I'm expecting a 1 0, right? If I print this out as a binary number, I'm expecting a 1 0. If I change red into the last 2 bits are 1 1, I call the function again, it should give me a 1 1. So you can test it out, it's gonna work. How about red 1, red 2? I said red 1 equals to red. So red 1 is this thing. Binary of red 1 is this thing. So the last 2 bits are 1 1. And I say red 2 is just equal to 0. So all clean. I want to put the first 2 bits of red 1 into the last 2 bits of red 2. So I say put 2 digits, red 1, red 2. So what I would expect this one would return is this thing would be put at the last 2 bits of red 2, which are just a bunch of zeros followed by 1 1. So it should be a 3. So this one would print out the 3 because 1 1 in binary is equivalent to decimal 3. If you say, I want to observe the bit pattern, just put this thing inside bin, and then you're gonna see it print out 1 1 with the bits to the left side being like all zeros. That would work. Any questions about this part? You just have to test them out, designing some values and see if the first 2 bits of red 1 end up at the last 2 bits of red 2. Nothing else in red 2 should change. For example, if I say red 2 equals to, this is red 2, I say red 1 equals to 0b, and I say 1 0, and whatever I have in here. All right, so this 1 0 should be put over there. But that's it. Everything else for red 2 should not change. Let's print out this. We'll end up with 110011, and the last two bits change into 10. That's exactly what we are looking for. Any questions about this part? And that's what you need to do for PA5. Okay, so um, for every pixels RGB, you got to do some bitwise operations to extract the right information, put it into the right spot. Okay, I think these are the exercises, and these are the solutions, I believe. Okay. All right. I think let's take a break. Okay, let's take a break. We'll come back. I will explain more about steganography. Okay, the details. I will give you maybe an example in here, and then we'll move on to dictionaries. Okay. So let's take a break. Come back 12 o'clock. And let's summarize steganography. Okay. So break time, everyone. Break time. All right, folks, we'll resume in 1 minute. Okay. All right, so um let's get started in here. So let's summarize steganography, right? So what are we supposed to do? In the PA5, you'll be asked to implement a few methods, right? Some of the helper methods to help you do the bitwise operations. But in general, you're looking at the secret image, and this is the context image. So this is the picture that you will send around. This is the secret you want to hide into it. So the encryption process would go like this. For every pixel in here, you find you have the access to the corresponding pixel in the context image. You grab the leading 2 bits from this pixel's RGB, put it at the last 2 positions of the RGB in here. And then you save the image, you will end up with this picture. If you look at this picture compared with the one above, they are, at least on the surface, looks exactly the same, although they're in kind of a technically different pictures. And then you say, I need to decrypt this original secret out. The way you do it is you're going to create a blank canvas as big as this one. We have a create image function from the CSE 8A library, right? And then for every pixel in here, what you do is you grab the trailing 2 positions of RGB, shift the result to the left 6 positions, and then put the result from step 2 into the corresponding pixel of the blank canvas. The color, the original color of the canvas can be anything. And then you save the decrypted image. The decrypted image and the original secret image will look different, because in here you have 16 potential meaning colors. In here you have 64 potential colors. But as you can see, you can still recognize it's a smiley face. Okay. And you will see these these boundaries in here that looks different. Let me show you one example. Okay. So this is an experiment I did before with another class I taught before. So this is the background. You see, this is just the background picture without any problem. And then what you can do is, my secret was a zoom screenshot, I believe. So where's the secret? It's a smaller picture. I think it's this one. This is a screenshot of the zoom picture in there. So what we will do is we'll try to hide this one into the background picture, and the result in here is you have the encrypted. This is the encrypted picture. Compared with no, not this one. Let's see, compared with the original. Where's the original? No, this is encrypted. Where's the original picture? This is the original picture. Okay. If you compare them, they are almost identical. It just right now I'm viewing them at the same size. They are identical. There is no difference between them, at least from human eyes. The the screenshot from Zoom is now hidden in here. You follow the steps to decrypt it, and this is what you end up with. If after you decrypt it, you will see that the original pictures up on the top, they have these colorations because of the 64-bit thing. And the remaining regions, in fact, they are like white noise. And that's expected because you are extracting the information from the last two bits of everything and put it in there. So you're going to see white noise, but part of it will be the original secret picture. And in here, the background picture is much bigger than the original picture. Okay. And that's what you need to do for steganography. Any questions about this part? Okay. So that's P5. I'm gonna work on it next week. Um, the remaining time for today will be devoted to dictionaries. Dictionaries are the last part of CSE 8A, okay, the curriculum. What we have is you have dictionary that is used to give you a mapping. So today we'll introduce what a dictionary is, look at the basic operations on a dictionary. And then coming back next week, we'll be looking at basically a CSV file processing, which use the idea of dictionary. Okay. So let's look at what is a dictionary. A dictionary gives you a mapping from one category to the other. Okay. So like what? So you can say I have a name to salary mapping. Given a person's name, you can find out the person's salary. Given the zip code, you can find the city name. Given the weight of a person, you can find their name and email to GPA. So they create this map. And that's what dictionary does. You have a key value pair. Keys are the things on the left side. Values are the things you get. So for example, you may have this dictionary, right, equals to Paul 3.14, Christine 4.4. And this would give me a dictionary of this is the key. So the thing on the left side is the key. And then the value over here, the value in there is the value. So we say dictionary is a key value pair. Given the key, I can give you the value. So give me the name, I'll tell you the GPA of the student. Paul is 3.14, Christine is 4.4. That's what we have. Okay. And if you look at the memory model, dictionary is an object. So in here, this reference variable is pointing to this dictionary object. The keys are in here, and this is the values. So the most important thing about the dictionary is, given the key, you can find its value very fast. That's the benefit of using a dictionary. It can really speed up the search process. Okay. If you only have like 20 data points, really you don't see much benefit of using a dictionary. But if you have 2 billion data points and you say, okay, give you a key, you tell me the value. If you use a list, it's gonna be very slow. It's gonna be very slow. If you use a dictionary, it is much faster. It is much faster. Okay. Um, let's look at some exercises in here. Okay. First, let's create a dictionary. Okay, let me create a coding strategy here. I think I have this coding strategy in there, but let's just do this on paper then. So can you create a dictionary called salary and put in the following data? So that's my salary. That's Mini's salary. For record, he has to pay us to work here. So how would you put this into a dictionary? I'll give you 1 minute. Okay. So if you are able to do it, remember dictionary is curly bracket on the outside. Right? Square bracket means list. Curly bracket means dictionary. Parenthesis means tuple. Okay. So how would you create a dictionary with the following data? If you're able to create it, um, give me a vote. Okay. All right, one of us is done. Let's work on this together. So you have a salary, right? There's a name equals to curly bracket, key value pairs. So Paul space Chow with a colon to indicate, okay, this is a key value pair. The key is on the left side, value is 1, 2, 3, 4, 1, 2, 3, 3, 4, comma, and then Mia is 4, 3, 2, 1, 1. The last one is Rick, or the value is -5. You have curly bracket, that's what you need to do. Okay. Any questions? So how do I use a dictionary? You say, okay, what's the salary for Rick Ord? Say salary. You just put in the key inside the square bracket. It's gonna give you back -5. It's gonna say, oh, it's -5. And it can do this very fast, no matter how many things you have in this dictionary. That's the beauty of it. Okay. Any questions? All right. Um, Now, how about this one? I have this zip codes is a dictionary. Okay, it's a dictionary. Zoom in a little bit. If I say zip code 12345, what would you say will happen here? Let's vote in. Okay. So, in fact, 12345 is the real zip code for a town. I think Schenectady. I think it's in New Jersey. (92093) is UCSC. All right. So okay. So a majority of us voted, in fact, for the wrong answer, unfortunately. The correct answer is D. The correct answer is not A. How come? Because 1, 2, 3, 4, 5, this is the integer. Integer is the key in here. So, but you are using a string. So this is a string. That's an int. And that's different. If you just remove the quotes, it's going to give you A. But if you have the quotes in there, it's going to give you D. And the Python is not smart enough to recognize, oh, that's what you meant. No. So 1, 2, 3, 4, 5. If you use as an integer, give A, but if it's a string, it's gonna say I don't have a key. So it has 3 keys, right? 9122, 12345, 92093, but none of them is a string of 12345. So we can't do this. That's why D is the error. D is the correct answer. Yeah. Questions about this? So be careful. Okay. How about this one? The same dictionary and then say zip codes UCSD. What would you say will happen? All right, so let's see. Um, if you have learned a lesson from the previous one, in fact, the answer is D. UCSD is not the key. UCSD is a value. This is the value. This is the key. When you use a dictionary, you don't use the value. You are given the key, you give the key, and the dictionary would give the value back to you, not the other way around. So you're gonna see it's gonna treat UCSD as a key. Do I have a key that's called UCSD as a string? No. Then you're gonna see a error. How about if I say zip code 1? What would you say would happen? If you have learned a lesson, it's gonna give you the same error. It's gonna say the key 1 is not in the dictionary. So for dictionaries, you can't use indexes, right? For list, for tuples, you can use index, but for dictionaries, it should just be the keys. You provide the key, it will give you a value. Questions about this? Okay. How about this one? I do 1, 2, 3, 4, 5, and then I say pause city. I print this one. What would you say will happen here? Two of us have voted in. Okay. All right. D, I think B and D, right? More people voted for D, Pause City. D is the right answer. Okay, why? The way you use a dictionary is this, right? So you have a dictionary, you provide the key, and this part have two meanings equals to a value, for example. This part is if key is already there. If key is already there, then this is an update. You will update the old value into this new value. So in this example, 1, 2, 3, 4, 5 is already a key, but the value used to be Schenectady, now changing to Port City. So it is updated. The value that match with 1, 2, 3, 4, 5 is updated from Schenectady to Port City. But if keys isn't there, this is to insert. Say, if, for example, I say zip codes 55555 equals to La Jolla, then that new key value pair will be inserted. So when you do this kind of assignment, it has two meanings, either update or brand new insert. Okay. Questions about this? All right. How about this one? I'm trying to go through this for, I'm trying to use a for loop to go through it. Make it slightly bigger. I'm trying to use a for loop to do this. Whatever. So what will be printed out? I have a dictionary. I'm going through for each item in this dictionary. I print out this item. What would you expect to see here? All right, so we most of us voted for C. Um, that looks natural, right? Is that okay? For each of the item in here printed out, then should be the key value pair. Unfortunately, it's not. It's A. Okay. Why the A? Because when you go through a dictionary, the thing that is provided to you is this is the key. So that's the key. It doesn't give you the key value pair. So what if I want to get the value? You just say zip codes square bracket item. This will give you the corresponding value. So in other words, it just gives you the key and you can easily use the iteration of the keys to obtain the corresponding value. So just be careful in here. When you try to use a for each loop to go through a dictionary, you are actually going through the keys. Okay. So in essence, the dictionary mostly deal with keys. And they store keys in a special format, in a special data structure that you will learn in future CSE classes if you're going to take more CS classes. Okay. Any questions about this? Just want to remind folks what we have in here. How about this one? I have zip codes 92122, same thing, and I say 1234 in zip codes. Is this true or false? Or it's going to be an error? right. Um, most of us said A, that's true, right? So 12345, it is in the zip code. So again, it's checking the keys, right? Is this thing part of the keys for this dictionary? And the answer is yes. Okay. Any questions about the basic idea of dictionaries and how to use it? All right. Then let's do this. Well, this is the last thing I have in here. We can probably do more today. So coding challenge. Can you write this function? Define color frequency count. So you are given a 2D list of tuples, like a picture. Our job is to summarize the occurrence of how many times each pixel occurred. In this example, this all white pixel occurred 4 times, all black pixels occurred 21 times. So this function should return a dictionary. This function should return a dictionary. The coding challenge is in here. Okay, so let me give you all this coding challenge. Can you write this function yourself? Okay. And we will probably talk a little bit more about other stuff. Okay. So work on this. Once you are done, give me a vote. Okay. Once you are done, give me a vote. I think we can continue today. Okay. We and then next week maybe we'll do a lot of reviews and practices. So we don't have to finish early today. So try to summarize this. Okay. And once you're done, give me a vote. No one has voted in yet. No one is done yet. Okay. Um, I'll give people one last minute. Okay. And then we'll work on this together. All right. Looks like no one is able to solve it as of now. Okay. Let's okay, one of us solved it. Good. Let's work on this together. Okay. So we're given a list of dictionaries. For example, I already have this image created. I just want to print out the summary in here, right? So how do I do this? First thing, you got to look at the dictionary. You got to create a dictionary that is empty. And then what you do is you want to go through this 2D list of tuples, right? So you can say um, h equals to the height of image, and then w equals to the width of the image. And then you go through every pixel for I in range of h, for j in range of width. And what we'll be doing is we will be looking at the ijth element of the pixel. It's RGB. I mean, technically, you don't even have to do this, but just to make things a little bit clear. So I have RGB, okay. And then I would insert it into the dictionary if it already is there. So I need to check if RGB, this tuple is already in the result. What I would do is after result square bracket, I will use the tuple as the key. Increase its value by 1. Right? That's what I do. But if it's not in there, I will say result RGB. I will insert this new data and give 1 to it. In the end, I would return result. It's important that you use this to check because If it's not there and you start to increase by one, that's a problem. Okay. Any questions? So you create a brand new empty dictionary, and for each pixel, you decide whether this is more like an update. This is more like a brand new insert. Okay. So let's run this. So Python code.py. Yeah, it's gonna give me these summaries here. For example, if I change this one into a one, it's gonna tell me there are three different kinds of pixels. There's this pixel that occurred once. 000 occurred 20 times now. White pixel 4 times. Any questions about this part? Okay. So I think this is the end of the notes I prepared for today. Obviously, we are done early, and we will continue. Okay, so we'll move ahead a bit more today. Well, first, before we continue, are there any questions that folks have about dictionaries so far? All right. So then let me move forward a little bit more. Okay. So we will move on to talk a little bit more about dictionary. Um, nothing fancy in here. Then we'll call it today. Okay. So I've updated the notes and I will put it into our add stem. Okay. Just because normally we have a lot of interactions during class, but it's online, so the amount of interactions is not as uh, extensive as before. Um, so a few things about dictionaries. Number one, we have seen that almost everything can be used as a key in the dictionary. We have used strings, integers. Now, what can't be dictionary keys? So which one do you think is the right answer in here? Let's vote. Okay. So which ones are not going to be key, cannot be used as keys in a dictionary? Which ones cannot be used as keys in a dictionary? All right. A lot of us said voted for B, cannot be used as keys in dictionaries. We just use tuples as keys in the dictionary. Look at this. This is a tuple. We just use it as a dictionary key in here. So key is in fact right. You can use tuples as keys. So what can't be? A list can't be a dictionary key. A dictionary cannot be the key. So in fact, D is the right answer. Okay, let me show you. What does it mean? So let's get into Python here. So for example, you can say a dictionary D equals to like a tuple 1, 2 map with like Paul, and this is fine. Oh, I miss a double quote, but yeah. So this is fine. A tuple can be a key. But if you say, let me say D equals to a dictionary, but I say this is a list mapped with Paul, the problem is it's going to say unhashable type list. In other words, you cannot use a list as the key. A list can be the value though. So you can say D equals to a dictionary with Paul being the key. and the value is 1, 2, 3, and that's fine. That's fine. But lists cannot be the keys. Why? It's because the dictionaries they use a special way to store the keys. And there's no way that a list can be stored in that special way. That's kind of the reason why. Okay. The way to do it is called hashing. So a list can't be the key, neither can the dictionary. So if I say 1 colon 2, this is a dictionary. I say you map to Paul, and this again is going to give me the same mistake. You say, oh, unhashable type dict. So this dictionary cannot be the key. Similarly, this dictionary can be a value. And this is fine. Okay. So if you say the Paul is going to give you this dictionary 1 to as the value. So just be careful in here. Any questions? All right. So let's come over here. I have this dictionary. Okay. So right now, what we are doing is we are practicing hierarchy. It basically means you have a dictionary, and this dictionary is fairly complicated. So its key or its values are not just simple integers or strings. Like in this example, if you look at the keys are the strings, the values are tuples. So, and they represent the location of San Diego, Madison, and Chennai. So what will be printed out in here? If I say city to location, Madison, 1. Can we vote in, please? Okay, so vote in. Whenever you're ready, what should be printed out? In order for you to analyze this dictionary, you must understand the hierarchy. Right? You must understand the hierarchy. Whenever you have a square bracket, you are going down 1 level in the hierarchy. Okay. All right, let's take a look at it. The popular vote is C. Okay, and in fact, that's the right answer. So C is the right answer. Why? Because if you look at this city to location, this is first thing is a dictionary, right? By default, it's a dictionary. So when I give you a key as the first layer of bracket in here is Madison. This would give me the value. So this map to the value is 43 and then negative 89. That's a tuple. And then this square bracket 1 is indexing into the tuple. So I'm looking at the first element of this tuple, which gives me this thing, negative 89. So it's not multiple layers of keys. The first layer of key would already get you to the value level. And now, depending on what the value is, you're going to go down the level again. Okay. So, any questions about this part? All right. Um, let's look at the last topic for today. I think we'll finish very early today. It's strange, but it is what it is. So we'll have the last topic, in fact, for the entire CSE 8A is list of dictionaries. And we will talk about this when we try to process CSV files. Okay. So when you look at a list of dictionaries, every element in this list is a dictionary. So the highest hierarchy is you have a list. And then in this list, you have a bunch of dictionaries. Right? Just like a list of lists is like the image. In here, you have a list of dictionaries. Each element in the list is a dictionary. And we use this kind of hierarchy fairly often. Okay. And the way that you analyze it, you have to be patient, right? If this is D equals to this, the first thing is you know D is a list. You know the list, you must use some sort of index to access the list. This would allow you to access this 0th dictionary. And then you may give you a key. And now you are in the value level. Once you are in the value level, and depending on what you have, you can keep going down the level. In other words, this is the highest level, going from high to low. And this is important. Okay, this is important. Any questions? Okay. So I think we can just finish the entire exercise and then we'll skip the break and we'll finish early today. Probably we'll finish around 1 o'clock today. Let's practice these ones. So if you look at this one, words, the highest hierarchy is this one. So what does that imply? Right? And so if I say words one, Paul, what would I expect to see here? Let's vote in, please. All right, a lot of us said A. I think that's the right answer, right? Why? Because words is a list. Words one, we're referring to this data in the list, which is a dictionary by itself. And then that dictionary, if I use Paul as the key, it's going to give me the value back. So it's going to be A. Any questions? How about the next one? Which one of them is going to allow me to add a new element to the list? Which one of them would allow me to add something to the list? Let's vote in again. What would you say? Which one of them would allow me to add something to the list? All right. So we will stop the vote. A lot of us said B, right? This is how you append something to a list. So full bar 3, this is good. Right, this is I add another thing to the list. The other, well, one of us voted for D. So how about this one? Words 2 equals to that. You cannot use an actual index to insert. This would cause an error, right? So because if you use an index that is out of bound, you're going to see an error. So the only way that you can append something, add something to a list is through append. You cannot use this approach. This approach is more like the way to add something to a dictionary. This is not the right way to add something to a list. Okay. Questions? How about this one? I have this one. Okay. So this one is not necessarily a list of dictionaries. This one is something else. What would I expect to see here? Let's vote in. So you got to look at the hierarchy. What's the top level type? And then what's the next level type and etc. Right? So we're gonna print out this thing. What would happen? It looks like we're getting this one. Okay, out of the votes that came in, we're all voting for the correct answer so far. All right, so let's work on this together in here. Okay, so what happens? First, this cookies, this is a dictionary, right? So how do I know it's a dictionary? The highest level is dictionary. And the keys, they are like strings. So the keys here are strings. The values are in fact other dictionaries. So if I say cookies pythonnews.com, this is the key. It's going to return. So this part would return the value, which is this dictionary. So font preference Korea section is XGKE. And then I do another round of key value pair. So now I'm looking at for the value. If I give a key at session, what will it give me? Is XGKE. So C is the right answer. C is the right answer. Yeah. So we're going down 2 levels on this dictionary. Any questions? All right. The last one. This is indeed the last exercise. This one is a little bit tricky. So look at this whole thing. And what does it do? What does it do? So what will be printed out in the end for this result? Okay. Oh, one of us got this really quick. Let's see. Yeah. I think we finished everything for 8A very quickly. Um, and next week is mostly just prepare for the final exam. Interesting. All right, vote in once you get what this code does. Okay. So let's work on this together, right? So what does this one do? Everyone voted for E, who have voted in, and I think E is the right answer. Right? The first thing you got to know is, okay, this course is a dictionary. And I inserted a bunch of key value pairs, number, name, people. So this people is the key. The value is another dictionary. Result equal to 0. For K in courses, so this K represents the key, right? So the first value that K would take is number. The second value is gonna, the second key is name. The last key is people. And I'm saying, oh, one K is people. And in here, I'm trying to process this dictionary in there. So for T in courses K, basically courses people. That's basically what I'm saying. Courses people is this value. And if you look at T in courses value, this T, the first thing it will take is preps. And then it's going to take TAs and etc. So this is the double indexing here. Courses K is courses people. And then T would be the keys for the dictionaries at this level. So you're adding them up. In other words, 1 add with 2, add with 33, add with 600, you get 636. In the end, you print out the result. So to summarize in here, what do we have? We have these two levels of dictionary. How do I go down the level? You either use, you can use square bracket in here. And a lot of times when you use a for loop, the for loop would also allow you to say, for each of the things in the structure, you are going down the level. If it's a list, you use the range, right, to go through each of the data in the list. For a dictionary, you say, for each of the keys in that dictionary, I'll do something. So long as the key in here is to make sure you know where you are, know the level that you are currently sitting at to avoid problems. Because if you're not sure which level you are in, then there's no way that you can correctly find out how to get the data at that level. Are there any questions about this exercise? Okay. Yeah, like I said, we finished early, but so be it. Next week, we'll just come back and do a single lecture on CSV file, and then we'll do the final exam review. Are there any questions in here before we call it a day today?